invited me to come here and put me a lot of hard work to prepare the talk. But I have learned a lot to come here, so thank you for inviting me. Today I will talk about the three tragedies of Japan, what we all know about it. Oops. Oh, okay. Oh, okay. The three tragedies are the earthquake, tsunami, and the nuclear power plant crisis. And what about the future of Japan? I think all of us hope that Japan will be recovered very soon. We plan for it. At the right-hand side, you can see that this is the clock that's, sorry, this one, clock that stopped at the 2:45 something, at Japan Standard Time. Mean when the earthquake starts at this time. And it is the clock that stopped when the tsunami come to this place, because the tsunami arrival time will be different along the different area. In Thailand, 2004, I think this may be a little bit fortunate for the Japanese people because it's after lunch, so I think most people already have lunch. But 2004 tsunami is occurred at 7 a.m. in the morning, and on Sunday, 26 December, after the Christmas time. So many people are still sleeping, after the party on Christmas Eve. Even in Thailand, so but it takes about 2 hours for tsunami to arrive Phuket Island. And on that day, many people didn't have even breakfast, lunch, and dinner. So very sorry for them. I thought the number is still increasing because the person killed and injured and missing. Missing, if we live for a few years, is also dead. And the rest, that many people still in no home to live, and the building damaged. And destroyed. Reconstruction should take at least 5 years, but I hope Japan can reconstruct very soon because Japan is a rich country. Inundation affected about these kilometers of land and caused 25 million tons of rubble and debris in Japan. And many automobiles destroyed and also delayed the production of automobiles. And this is the damage, cost a lot of money. And only Fukushima power plant, this is the loss, it's also a lot of money. The earthquake and tsunami caused extensive and severe damage in Japan, including heavy damage to bridge, roads, and railways, and edifices in many areas, and a dam collapse, and caused a number of nuclear accidents, result in the associated evacuation zone, affecting hundreds of thousands of residents, and about 4.4 million households in northeast Japan were left without electricity, and 1.5 million without water. That's very bad. And the Prime Minister said that in 65 years after the end of the World War II, this is the toughest and the most difficult crisis for Japan. The first one is the earthquake tragedies. This is the most powerful known earthquake to have hit Japan, and one of the 5 most powerful earthquakes in the world. Oh, we have Dr. Ueda here. So if anybody have question about earthquake, please ask Dr. Ueda. Not me. I'm not expert on earthquake. The earthquake moved Honshu 2.4 meters east and shifted the earth on its axis by 10 and 25 centimeters. The fault involved in the earthquake was thrust upward 30 to 40 meters and slipped over an area of 300 kilometers long by 150 kilometers wide around the mass of Switzerland. When I study about this earthquake, I have questioned that the earthquake magnitude of Japan is less than the Indian Sumatra earthquake. But how come the tsunami from Japan earthquake is still higher than the Indian Ocean tsunami? So I will try to answer my question. And I need, discussion because I think I'm not an expert on anything. I just started studying tsunami after 2004. So my background is only wind wave. And I'm not expert on earthquake or even nuclear power plant. So we should like to have more discussion. So anybody can answer the problem. Please do welcome, and you can interrupt my talk anytime. So you can see that, oops, sorry. First 9.5 Chile in 1960, and the second one 9.2 Alaska, 9.1 Indonesia, that's December 26, and 9 Russia, November 4. This is my birthday, I can't remember. And this the fifth one is the Japan. I think I took this from the USGS. It's a local time about 2:46, and epicenter and the hypocenter and underwater depth 32 kilometers is rather shallow earthquake. So not only the magnitude of the earthquake that caused tsunami, but the depth also important. And duration 6 minutes. But for the Indian Ocean earthquake, it lasts 10 minutes. And this is the epicenter distance from main city. And the geology of the subduction zone. Hypocentral region of this earthquake extended from offshore Iwate Prefecture to offshore Ibaraki Prefecture. JMA, Japan Meteorological Agency, said that the earthquake may have ruptured the fault zone from Iwate to Ibaraki, a length from 500 kilometers and a width of 200 kilometers. This earthquake consists of a set of 3 events. This area is smaller than the Sumatra earthquake. I can compare to you later. The earthquake may have had a mechanism similar to that of another large earthquake in 869, with an estimated surface wave magnitude of 8.6, which also created a large tsunami. Other major earthquakes with tsunami struck the Sanriku coast region in 1896 and 1933. I think if you have questions about this, please ask Professor. So this is the anatomy of the earthquake. I think we know about the subduction zone. And, this is Japan, Ocean. And this is the Japan Trench. And a west to east section through the Honshu coastline showing the location of the main rupture and any close to the shore at the depth of 30 to 40 kilometers. It's very near the shore. So it is the, for tsunami we call near field earthquake and tsunami. The quake occurred when slowly accumulating strain was released when the Pacific tectonic plates collide with a thin sliver of the North American plate, backed by the Eurasian plate. So I think the configuration of the plate here is rather complex than the Sumatra subduction zone. It's rather linear, but here many plates, Pacific plate, Okinawa plate, I cannot see very much. So many plates. So this also affects the mechanism of the earthquake and tsunami. This is the total earthquake tectonic effect. So this is the figure of this rupture zone smaller. And the center depth is about 20 to 25 kilometers, rather shallow. And in the water depth, about 8 kilometers. This water depth also affects the tsunami. And after earthquake, because it's a megatrust and big earthquake, so it caused a lot of multiple segment rupture. So I cannot explain very much. In March 11 quake, several segments slipped simultaneously, something that may not have occurred here for 1,000 years. So I think most Japanese seismologists do not expect very large earthquake in the Japan Sea area. So this is an unexpected earthquake. On July 13, 869 AD, appeared to have resembled the 2011 event in that its tsunami also flooded the coastal plain near Sendai. These figures are that from the Japanese seismology. This one. You can see that this is the area of the rupture area. So not very big because of many plates. And when I compare with the Sumatra earthquake, this is when the earthquake here is similar. Is the near the center, epicenter. It caused it lasts 10 minutes, and it caused the rupture length of about 1,300 kilometers. The longest, the largest rupture ever known to have been caused by an earthquake. And magnitude 9.1, more than the Tohoku earthquake. For my idea, I have to ask Professor with that. I think the earthquake spent a lot of energy for the rupture lengths, and it is rather linear feeders of the subduction zone. Not like in Japan, you see, many small plates come together. So this is the area of the rupture zone. Length 1,300 kilometers, depth 30 kilometers, and width nearly the same as a Tohoku earthquake, 150 kilometers. And it is compared to Tohoku, Japan earthquake tectonic sampling. So this is the small area, not very much. And center on the earthquake epicenter along strike, while peak slip were upbeat of the hypocenter towards the Japan Trench. It is the Japan Trench axis. It is the epicenter. And the March 11 was preceded by a series of large foreshocks, not precursor, like Professor Uda said yesterday. This is foreshock different? Mm-hmm. Okay. Thank you. This is the historic earthquake activity near the epicenter. This is a star, and this is the subduction zone. You see, deeper. Increased to 300 kilometers, that's blue dots. Toward the west, this is the section of AA5 here. If we see the slip distribution cross-section of Indian Ocean tsunami, you will see this. This is about the depth, and it is the strike kilometer long. You can see that concentrate around here and expanding. And compared to the slip distribution of the Tohoku earthquake, you can see that it's rather concentrated here. This is the epicenter. Look again. This Indian Ocean, this is the Tohoku earthquake. Cross section of the slip distribution. It's because it's the big earthquake, so it moved the Honshu Island. So it can move the whole, oh my goodness, the whole island. If it occurs in Taiwan, move all Taiwan. This is the bigger island. So forward prediction by GPS vector measurement. It is the final fault model by USGS This volume 1, 7 hours after the earthquake. So this is the compact rupture, mostly bilateral above epicenter. Peak slip up dip of hypocenter. Rupture was likely restricted to the shallow trench, and GPS vector suggests slip did not reach the plate boundary beneath the coastline. Peak slip closer to 30 meter infer from update modeling. So USGS update the modeling to volume 2 on 18th of March. So here, this is the epicenter. Update modeling show peak slip of 30 meter depending on the parameterization of rupture velocity. Velocity also important. This update model shows peak slip of minus 32 meter using a range of rupture velocity from 1.25 to 3 km per second. Models with constant rupture velocity show slip of 40 to 50 meter or at shallow depths. Shallow depths cause a lot of tsunami. This may imply that the updip nature of rupture is well resolved, but peak slips are not. Low slip region near the fault edge and fault base are as poorly resolved. Another data about surface projection of the slip distribution superimposed on the Itopo 2. The red dots are the aftershock, after the main shock, and the vector indicate the plate motion. This is Pacific plate motion, 8.3 centimeter per year. The black line indicate the major plate boundary. Preliminary modeling by UCSB scientists indicate that, this is from British scientists, the most extreme seafloor displacement during the March 11 earthquake occurred in very deep, about 4,000 meter water. This also affects the height of the tsunami. The rupture process of the earthquake found directly on the distribution of the seismic ground motion. The first massive rupture occurred at off Miyagi. Miyagi is a very strong earthquake here. Strong seismic wave was released all over Tohoku. This is the purple line. And after several tenths of seconds, another massive rupture occurred and a strong seismic wave was released. Light blue. That's the light blue. The second one. Further, the distance from the rupture starting point, the arrival time of the seismic wave will be delayed by the second rupture light blue time lag caused by the distance is short. This is the second event, and for the third event, this indicates that this second rupture occurred at the offshore far away from the land. Then immediately, the third rupture occurred at the offshore near land of the northern Iberity, the red one. And strong seismic waves were radiated toward Iberity Prefecture and Tochigi Prefecture. The rupture property and the radiation characteristic of the third event have been different from the others because the release of the third event is not as clear as the acceleration record on the displacement waveform record. So we have 1, 2, 3 events. It should have some, some moving. The start of the earthquake and the strength of the, this is the date and the size of the surface, the magnitude. I think this from the German Institute Helmholtz Center. So, this is the time. Okay. And it is the topographic effect. Topographic also affect the earthquake, rupture zone, and also tsunami. Relative horizontal displacement by GPS 5.2 meter maximum. Displacement on rupture surface 25 to 27 meter. Rupture rate 400 kilometer. Seabed lifting up to 7 meter. So, and this one is the area moved to east-southeast 50 meter, uplift 7 meter. And then lateral slope Tohoku. This is the two times circle. This is the Japan trench axis, landward slope of Tohoku Arc, seaward slope Pacific Plate by Jamstick. So please get the data from Jamstick. And this another one is the profile. These two, the red profile, one here and one here. Seabed change after Tohoku earthquake. And this is the reference. So if anybody has question about this, please ask Dr. Hill. The main earthquake was preceded by a number of large foreshock and 1,000 aftershock. This is the foreshock, about three. And there is the foreshock, main shock, and aftershock still go on from up to 9, they said maybe 1 year. And it is the main shock, possibly related earthquake, and the aftershock just still continue for years and will taper off in time. So this is the Tohoku earthquake and aftershock on March 11 to 14. And it is the decreasing of this is the main shock and aftershock. Energy of the earthquake, I will go very quickly because this is tremendous energy. But you see, energy is double of the Indian Ocean or Sumatra earthquake. That's very important. So it creates a high tsunami. If we can get the surface energy from this earthquake, it would power a city like Los Angeles for entire year. And this is a lot of energy. So I think we can find from any document. And the largest individual record in Japan was 2.7 G in the Miyagi prefecture, 75 kilometers from the epicenter. The highest rating in Tokyo was 0.160. So this is from seismograph around Japan. This you see in record in Miyagi prefecture. Geophysical impact. A city of Sendai is one of the hardest hit areas, initially moved up to 4.6 meters to the east before spring back to the west about a yard. The quake actually chipped the entire island of Honshu to the east more than the west. Data from more than 1,000 GPS over a period of about 3 minutes. Honshu expanded to the west up to 3.6 meters, adding new land equal to 150 soccer fields. GPS station data provided Japan had gotten at least 4 meters wide. Oh, you got more land. And the quake moved portion of northeast Japan by as much as 2.4 meters across to North America, making portion of Japan landmass wider than before. Portion of Japan closer to the epicenter experienced the largest shift. This new land had been lost to the slow squeezing action of the west moving Pacific plate. And the earthquake enabled it to spring back to its 18th century shape. Oh, a lot of movement of the Japan. So, and recorder on the seabed also record about the movement larger than on land. So I don't like to go over in detail. And the sea floor also move, and the coast. This floor assembly is moved more than 20 meters. This direct measurement exceeds the displacement suggested by some models built only from the data gathered on land. So the data from the seabed is also important. Results show that how important offshore data are to know where and to what extent the rupture occurred on the plate boundary. And it is the monitoring the movement caused by the Japan earthquake So you can see Miyagi Prefecture. Horizontal 24 meter, vertical plus 3 meter, largest movement in Miyagi Prefecture. This also slow. A station known as MYGI. MYGI. This show the movement. This also MYGI. And this show the movement of the land. Record land mass movement has been observed in Miyagi. I have to go on very quick about this. So a lot of important thing is uplift of offshore region and subsidence of coastal land. It's very important because when you get the subsidence of coastal land, the seawater can enter or penetrate in the longer distance and make the tsunami higher and further inland. This last one about Noah bathymetry image by Itopo one dataset. This is the Japan, see? So it's the Japan Trench very near the Japan island. Ground motion intensity. This is also earthquake parameter. I said maximum is at Kurihara Miyagi Prefecture. So this is the epicenter here, Miyagi around here. And it's, the earthquake lasts for 6 minutes from this seismic ground. And maximum acceleration, maximum displacement of ground motion using the KNET observation station, Miyagi Prefecture, near the hypocenter. And they record a lot of ground acceleration. This is the peak ground acceleration. And this PGD also peak ground displacement. A lot of displacement, especially here, near the epicenter. And the maximum 2 places in Ishinomaki and Rikusen Takata. Land subsidence, not only uplift but also subsidence. So these are the data from many places. And the largest one is subsidence in Iwate. And then 40.78 meter. And this third one, Miyagi also. And you can see the land subsidence and soil liquefaction cause a collapse of building. This the risk of submersion and flood in this region when the coast subsides. So, as I said, the tide gauge data show that higher about this ground sink and will increase the tide level. And from the satellite image, Astro, you can see that this city, Rikusen Takata, before tsunami and after tsunami, and this is the area photograph. Soil liquefaction is a factor for earthquake. So this is the liquefaction, and this is land crack. So many, this landslide, goodness, they're going to their home, not safe. And this is from aerial photo, Sendai. And at that night, people, got stuck, sleep in the car. It's cold in March, the effect to the ordinary people. And global impact. I think yesterday, Dr. Hill, they talked about rotation of the Earth, something like that. This also affects the global Earth rotation, spin, and this is vibration. And I stop about the earthquake. Anybody has question? If not, I proceed to the second tragedy, tsunami. After earthquake occurred, because it's near field, so only few minutes tsunami occurred. Not like in Indian Ocean tsunami, Indonesia is near field, but Thailand is far field. We have got 2 hours for evacuation, but at that time, no warning system. So we have to prepare about oops. So tsunami tragedy caused by 5 to 8 meter upthrust on 180 kilometer wide seabed at 60 kilometer offshore on the east coast of Tohoku, result in a major tsunami which brought destruction along the Pacific coastline of Japan, Northern Ireland, and result in the loss of thousands of lives and devastated entire town. The tsunami propagated across the, I think this gentleman will show in the South Pacific region. So this is the mechanism of earthquake that cause tsunami. Usually the tsunami, I will show you the direction later. Several factors contribute to the tsunami's enormous size, including the magnitude of the earthquake. As I said, 9 is very much for the magnitude, but not only the magnitude that caused the tsunami, the depth, also depth in the earth's crust, 24 kilometers beneath the earth's surface is rather shallow. If it's too deep, it doesn't cause tsunami. Overlying water column of the triggering earthquake, the size of a tsunami is also determined by both the amount of elevation change on the sea floor and the depth of the overlying water column. This difference in water depth over area of greatest energy release produces a difference in amplification as the tsunami travels from the source region toward the shore. The parts of the sea floor may have risen as much as 9 meters during the March 11 earthquake. The primary direction of tsunami wave forecasting which affect the distant or far field impact of the tsunami. So all of these factors will determine the size of the tsunami. This is the maximum wave amplitude by country, mostly in Japan, but also in Northern America and in New Zealand. And this from Facility Talk, using the Morse model. I compared the Indian Ocean on the 26th. The source of the tsunami is not the point source, but is the line source, because the tsunami direction is normal to the axis of the fault. So this is the fault, here, 1,300 kilometers long. So the tsunami express, but in Indian Ocean, you see many islands and bathymetry and coastal area and continental also affect the distribution of the tsunami. And you can see that this compared to the Tohoku. Normally the directivity of the maximum wave amplitude is normal to the axis of the fault line and is east-west direction. So this is Thailand. So we get higher wave, tsunami wave than in Myanmar or in Bangladesh. And because of the dynamics of the subduction zone, explained to me that the subduction zone here is from west to east. So usually the first wave tsunami wave is the trough leading edge. When the trough leading edge, because of the position of the subduction zone, it will cause higher tsunami than the crest leading edge along India and Sri Lanka. But for the this also Vasiliki Tom used the most method of splitting the tsunami forecast model. For the Japan, you see the fault lines. So it's the effect along this direction and across to here. So Alaska is not very serious, and Taiwan, there's Taiwan. So I think it doesn't affect very much of Taiwan. And Thailand. high gauge radar along the Andaman Sea coast of Thailand to detect the arrival time of the tsunami along the coast of Thailand. So it arrived different time. So this Fukushima here, Miyako. Sendai Airport is here. That is Miyako. Main damage area. This is the tsunami wave height that's surveyed by many teams. You can see that the part is here. And it is tsunami wave height. It is detection. Also, JMA also surveyed the tsunami ground. Very high near the epicenter. So, Perry Port and then Port Research Institute, the Thai system the data. This many data from real data from Perry observation. This also. Okay. How many minutes? I have to be quick. So at the Ofunato, 30-meter high, and Taro, 37.9. For Indian Ocean tsunami, the highest, less than 35 meters in Badaji. But here is higher because of the factor that I explained. This is the Taro district, Miyako City, our prefecture. You see, there will be a lot of complicated breakwater. And here, 38.9 meters, very high. And this used to be underneath the tsunami a long time ago. So they moved. I think you said about the hill people, they want to rebuild the same place. It's not safe. But here they moved inland, so it's safe from the tsunami, this tsunami. Because it's no longer safe. And you can see this, the person very high. On 13 March, this also many record or observation. Yes, you see a lot of. Here, Paris survey, 37.8 here. This is the coastal defense cannot protect the port anymore. Kamaishi Port. I was invited by Paris to visit this area to see the tsunami mitigation. I very much impressed about it. It is me on 9 August 2006. Very tall, 63 meters. And they also have video watch 24 hours. And it's very funny because they have the Guanyin goddess to protect the coast, but she did not protect the coast this time. Sorry for them. So after the tsunami, see, they destroy. And there is, if you have the seawall, cannot withstand the force of tsunami. This near the Sendai airport. This April, and this after, before and after. You see, many offshore breakwater cannot withstand the tsunami. Ofunato port. Yes, this 23.6. This by Paris. Fudai village. This can stop tsunami. Sometimes it can stop, but not all. Sometimes the wave overtop the seawall, so bring the debris. Also, they took us to see this seawall very high, you can see, and it's already broken. You see, after that, after tsunami. And what did we learn about breakwater? Very strong breakwater, except one could not stop tsunami. It means that hardware could not be relied on. While software, such evacuation and communication system work much better. I think we learned that education is also important. If people know how to escape the tsunami, they can help themselves. Not even they don't hear any siren or warning. This is the strength of the tsunami wave. Natori city in Myanmar. This one is very famous, like the wall of the tsunami wave, Natori, before and after. And it is in Natori too. You see, destroy and bring sediment. And it's also Sendai Newport at 3 points. You remember the earthquake occurred at 2 points. Something. This arrived at Sendai port about 3 points, 56, maybe about 1 hour later. And this caused swell, turbulence, because, as I said, run up and run down and meet together. And it is we call inundation map is very important for evacuation plan and for risk management plan. So IOC support all nations to produce this kind of inundation. This is Myanmar prefecture. This also in the graph. We have to use the modeling, tsunami modeling, and the GIS and satellite data to produce this kind. And because for tsunami modeling, we can model any magnitude of earthquake and inundation distance. So we use the worst case scenario to produce this kind of inundation mapping. I stop about the second tragedy. Any question? If no more question, how many minutes? I can go quickly about the nuclear tragedies. Because you know that in Japan, 30% from coal, 25% from gas, and 24% from nuclear. But it is in 2008. But now, I think they use about 30% of the 70 nuclear plants. And they plan, but right now I think they rethink about it because of this tragedy. Because Japan has few natural resources, so Thailand is richer for this sense. We have oil and gas and coal and many and forest. And the Fukushima Daiichi is rather old and use old technology, boiling water reactor, and about 33 years ago. So this is the red one is the nuclear power plant 4, and it is the epicenter. 4 power plants were affected, and it is the safety design, because they use the old design and safety design they use for, I think they use about, this is about something like 8.2 magnitude earthquake. And initial response, usually when the earthquake occurs, they stop the power plant, they stop the nuclear activities. But that's not the real problem. But because they built the seawall about 5 meters high, but tsunami come here, and you see they design for 8.2 magnitude. But tsunami overtopped the seawall. See, from this, tsunami overtopped the seawall. And when they entered the power plant and destroyed this cooling system destroyed. And it is the Perry measurement about the height of a tsunami. So the tragedy occurred. This is the all damage at Fukushima Daiichi were caused by the tsunami, not by the earthquake alone. Oh, okay, earthquake start the problem. This is the design of the cooling system. They don't design for if it was flooded by the seawater. So that's the problem. So damage. Seawater pumps. They have to cool down the rock, nuclear rock, unless it will melt down and explode. So this is the piping and capping system. It will flood and contaminate water. And they got explosion. From Fukushima nuclear power plant is no more sustainable. I think everywhere in Thailand we have not started yet, but we stop. There's nothing which is absolute safe. Or we talk about the global warming, so they like to use the fossil fuel. But what else could we use? So try to conserve the energy. In Japan, we cannot turn on the air conditioning more than 28 degrees. And don't have to wear suit to work. You see electricity loss on 12 March by DMSP satellite. So this is that's very critical because radioactivity release. And the town is here. So sometimes it's moved up to the city. And they have anti-nuclear rally. Not only in Japan, but other cities. So aftermath, I'm nearly finished. 8,000 people died at Otsushi, Iwate. And it is the maximum water height 19 meters, and the distance from the source 121 kilometers. 8,000 people is the number of deaths in Thailand for the whole Thailand, including the foreign visitor. But here only in Otsushi town, 8 people died. Yes. So I don't like to see this. If you go to Bandai to see the mass grave, it's not individual home, but it's a big pond or something like that, and they dump, the body, more than 10,000. So changing coastline by the tsunami, we can use the satellite data to study. I used to study the change of coastline in Thailand after tsunami by using satellite data and fly. And this is the same line. Satellite image can use. I think it's one from Taiwan. This from Taiwan. Satellite. You see airplane kiss the building, because in Thailand we have ship, a boat, kiss the house, and the bridge broken. That's cool. 100,000 children homeless. In Thailand, after tsunami, 2004, we have 1,200 orphans that we have to take care of them because no family anymore. This is the temporary house. This is the last one. I hope that there will be beautiful cherry blossom again in Japan, affected tsunami area. This is the cherry blossom in Yuan Ming Shan in Taiwan that I went. So I dedicate my work to all dead and live tsunami victims. Thank you.
Okay, thank you. There's Siripong's talk. Due to time limits, we can open one or two questions. Anyone?
It is not a question. I just want to say you made a wonderful work. I'm impressed.
Please don't ask me about the earthquake. I have to ask you. Okay, comment is good.
Yeah, that's my comment.
Okay, thank you.
So we close this morning's session.
And thank you advice 10. So next we will have a small.
Oh. Not diamond.
I think she's already got there.
Yeah, yeah. So I can.
Okay, and everyone can enjoy the cafe in this kitchen room. Now we can move there.